Question number 6.182. Find the number of natural transverse vibration of a string of length L in frequency interval from omega to omega plus d omega if the propagation velocity of the vibration is equals to v and all vibrations are supposed to occur in one plane. Okay. So basically, suppose we have a string which is fixed at both the ends and length of this string is L. Right. So vibrations are taking place and we have to find out number of natural transverse vibrations in the frequency range omega to omega plus d omega. It means between this gap for d omega. Right. And all vibrations are taking place in one plane. So if all vibrations are taking place in one plane, then wave generated in this string can be expressed as function of yxt, that d2y over dt square is equals to v square d2x, okay, over dx square. Right. In this way, this function will change. Okay. So now if we'll solve this expression, this x, t are changing, y is changing with respect to x and t. Right. So if we'll try to find out solution of this equation, one second. This is d2y with, second order differential equation. Then solution of this equation for a wave can be written as yxt is equals to a sine omega over v into x into sine omega t plus delta. Right. Here a and delta are positive constants, of course. Okay, so we are just taking general solution of a standing wave, nothing else. Okay, right. Now see, if we take for any particular time instant, let's take t equals to 1. So this parameter would not change. Right. So the value of y will depend on a sine omega v over x. Right, for any time instant. So for any particular time instant, we can impose two boundary conditions on this wave. First thing, when x is equals to 0, there would be no displacement, so y is equals to 0, number 1. Number 2, if x is equals to L, then y is also equals to 0. Okay, so we can apply two boundary conditions over this solution. Right. So if we apply second condition, that when x is equals to L, y is equals to 0. So we can write a sine omega L over v is equals to 0. So when this value will be 0, sine omega L over v. If this is equals to n pi, this implies if omega L over v is equals to n pi, then we'll get 0 here. So from here we can write n is equals to L over pi v into omega. Right. So if we differentiate this equation, then we may get dn is equals to L over pi v into d omega. So this is number of natural vibrations in this frequency range of d omega, that L over pi v into d omega.